Assalamualaikum to everyone. I am Amirul Aizat bin Abdul Qadir from Faculty of Innovative Design and Technology from UNISA. I would like to present my final year project, which is simulation and 3D design of innovative seed sowing machine. This project was supervised by Dr. Muhammad Firdaus Ashraf. The seed sowing machine was created to improve the seed sowing method from the old to the modern method. There are a few techniques used for sowing machines, such as broadcasting, beading, drilling, and others. The time taken to finish the sowing process is different according to the different technique used. The problem statement to overcome this project is the production of crop field becomes slow. The sowing process of the seed become longer can affect the quality of plant. Next is the total cost of production will become increasing because we need to wait the plant grow up so that crop yields can be taken. Lastly is the employer need to hire a lot of labor to manage crop farm. The objective that need to achieve for this project is firstly to design a 3D model of ergonomical seed sowing instrument. Second is to simulate a seed sowing instrument structure, and lastly to validate the 3D model design of seed sowing instrument. There are a few components used in this project. As we can look, the handle used for control the direction of machine. Hopper is a place to put the seed. Motor and belt used as power transfer mechanism to move the machine forward with power of 60 rpm. Then inside the hopper there is a component called seed distributor to move the seed into pipes one by one. The cultivator used for digging soil before being planted, and sliding plate used for close the open soil. The PVC piping is a cylindrical shape. It's a transport mechanism for the seed to fall off to the ground. And lastly, tire rod used to move the tires. Before we proceed, let's watch a video about application of the machine. There are several innovations that had been made to make this machine different from existing market. It is a semi-auto machine that uses DC motor with 60 rpm as primary source to move the machine from one point to another. This multifunction machine also have many features to help farmer in sowing seed, such as digging, cover up soil, and uniform distance of seed. This is a 3D model for this project. They have 4 different views, which is isometric, front, top, and right view. All this 3D model was developed by using Autodesk Fusion 360 software. For the first design variation, stainless steel is employed on all the main body according to the original design process to ensure long-term endurance. In the simulation, a load of 5 kg was applied to the handle and hopper, which matched to the typical weight of a human hand and energy to control this seed sowing machine. The handle area experiences a high pressure compared to the other component. At the back of handle there has a maximum value because on that area is where the user holds to control this device. It needs to accommodate pushing loads by user despite there is no pressure on the hopper as the load can exceed 5 kg of seed. Other than that, it has a maximum pressure value because on that area the part is hanging and not tied to other components. The handle is also an important part in this device as users need to control this device that run by DC motor. The handle must be strong enough to hold high pressure. We can see that the load is transmitted from the front area of the handle to the back area of the handle. Next is FEA simulations for the second design variation. PVC is used on the body and rubber on the hopper. This PVC is used to reduce costs because stainless steel is quite expensive. In order to become more stable as the body is made of PVC, the size of the handle is raised to 120 mm from 160 mm. The load is still the same for the first design variant comparison, which is 5 kg. There is a distributed load on the rigid body component. For the second design variant, the maximum value on the rear of the handle was lower than the first design variation. This shows that PVC is less appropriate for the pressure of the user's hand. On the middle portion of the handle, the load is dispersed and the durability of the device has decreased. The middle body using PVC might cause movement harm to the device. The use of rubber at hopper is not affected since it can accommodate load up to 5 kg. Last is the result of the FEA simulation for the third design variant. Because polycarbonate is both lighter and more affordable than PVC, the material for making the product has been changed. Polycarbonate is the most often used material for manufacturing since it is simple to install as well as easy to make custom. Because of its high mechanical strength and toughness, PVC has been used to replace stainless steel in the hopper. The size of the hopper has been increased in order to accommodate more seed feeding the hopper. The handle thickness is the same as before, 5 mm, but it is now wider. The burden remains the same in order to make a comparison with the other two design variations, which are each 5 kg. There is a slight increase in load when comparing the first and second design variations. With every design variation, the maximum value on the handle's back increases in value, with the greatest value being found between the first design variation and the second design variation. The use of polycarbonate for the main body load and PVC for the hopper might reduce the overall durability of the device by a significant amount. This machine was designed according to appropriate target customer, which is for nursery usage, small-scale farmer, and home gardening. That's all from me. Thank you.